Yeah. Good. Check. Okay. Hi, everyone. Welcome to FHIR DevDays and welcome to the first actual FHIR-related sessions. This is Simone here, and she will be doing introduction to HL7 FHIR. If you guys have any questions, feel free to post it on the Hoover Q&A. And also, we are monitoring, our other moderators are monitoring, live chat for Zoom as well. So feel free to post in that as well. Over to you, Simone.
Thank you. Yeah, welcome to DevDays, everyone. Since you are joining the introduction to FHIR, I assume that it's your first DevDays here. So welcome, and I hope that you will learn to enjoy it as much as I do. I have actually been on quite a lot of DevDays. I joined the very first installation of it back in 2014, and I've been to every installation of DevDays since. I don't even know how many there were because I kind of lost count, but it's been a lot. And I'm very happy that we are now, after all these trials and turbulences with the pandemic, that we are back here together in Amsterdam, like it was at the very first installation of DevDays. So clearly, you have decided to dive into FHIR at the deep end by joining DevDays and kicking off your FHIR journey with the largest community, the largest assembly of the FHIR international community. So I'm going to try to keep this short because I assume that you probably have a lot of questions, and I'm going to try to answer all of them, or at least most of them, or at least be able to point you to the specific sessions where you will get your questions answered. So my name is Simone Heckmann. I'm CEO of FHIR GmbH. We are a German company founded in 2016 that provides training and consultancy for FHIR in Germany and in neighboring countries. So I've been doing FHIR trainings for quite a couple of years now, and I've been doing a lot of these introductions at DevDays. So first, I'm going to try to explain a couple of all of these acronyms that are surrounding FHIR to you, because sometimes there's quite a lot of confusion about what HL7 actually is and how it relates to FHIR. You've probably heard people talk about the HL7 standard. And when people talk about the HL7 standard, what they refer to most of the time is this HL7 version 2, a standard that dates back to the 80s of the last century, and has been quite popular for many decades in many countries in the world. And it's actually often referred to as the HL7 standard because it was the one standard from the organization HL7 that was vastly popular everywhere in the world. But it's not the only standard from HL7. So with HL7 being the organization that developed this, they have quite a lot of different products over the more than 30 years of their existence. And FHIR is another one of them. So FHIR might as well be called the HL7 standard as much as this is, but the naming conventions in the public often decided that this would be the HL7 standard. So don't be confused if people talk about HL7 as if it was something opposed to FHIR or something contradictory to FHIR, when in fact the HL7 version 2 standard and FHIR are pretty much children of the same parent, the parent being HL7, the international company that develops these standards. Well, what you see here, this HL7 version 2 message, is how interoperability was designed in the 80s, in the mid-80s. And that's pretty much how it has worked for many decades in many countries around the world, and still does. HL7 version 2 is still largely popular. And if you're new to FHIR, but not new to the healthcare interoperability sector, you've probably seen quite a lot of this. And this representation of data affects the way we communicate in quite many ways, because the HL7 version 2 standard is an event-triggered and message-driven form of communication. So we kind of expect primary system that has all of the information that everyone wants to send messages to other systems, like subsystems in your hospital or external systems. And so these systems basically have to sit around and wait for the primary system to send them the information that they need. And in order to have this information at ready when they need it, they have to save it. So what we've been doing for many, many years was pretty much creating lots and lots of duplicates of our data across different systems. Because whenever a client, whenever a user needed a specific kind of information, they had to look it up in their own database. There was no way to efficiently query this information in the primary systems. And that's pretty much the approach, like the way we've been practicing interoperability for many, many years. However, now there are a couple of new challenges ahead, and they don't work with this kind of approach to interoperability. Whenever we create web-based applications that have to be lightweight, that don't bring their own database, their own persistence layer, when we want to create mobile apps that aren't permanently able to receive messages from other systems, when we want to have patients participate in this environment, when we need complex IT systems like decision support or machine learning or big data analytics, this kind of communication doesn't work for these new challenges that we have. So we need a new approach to interoperability. But it's not really that new, because everywhere else it's already happening. These challenges are not unique to the healthcare sector. We have plenty of other use cases around where we already have solved these problems, whether it's weather data that you need to have present in your mobile phone, whether it's booking or planning a trip where you need big data that has been collected by over years, and you have machine learning algorithms that track the fastest way from A to B for you. These problems have already been solved, but in a completely different manner that has nothing in common with the way interoperability has been working in the healthcare sector. So these three guys sat together back in 2011 and thought, what if we use these approaches that we're already using successfully in other domains and transfer them into the healthcare sector? What if we used patient data and granted access to patient data the way that we access weather information or booking data or prices from Amazon products and stuff like that? And the answer is pretty much always the same. What we need is an open API. That's the way the things work everywhere else. If you have a system in the cloud that has lots and lots of data that other systems need to have access to, that other systems want to use, you provide them with an open API, a programming interface that everyone can use to access and retrieve the information whenever they need it, wherever they need it, in just the amount that is required for their specific use case. And so these three guys started to write a specification that would transfer these open API ideas into the healthcare industry. And fortunately, all of the three guys that invented FHIR back in 2011 are still active in the FHIR community. So we didn't have the big clash, the big bang, where someone stomped their feet and left and everyone else went in a different direction. We are still the same happy family that we were like more than 10 years ago. And you can see all of these three guys hanging around today at DevDays and ask them anything you want. They are all very, very nice people. I love them madly. And I'm really glad to see them after many years when we didn't meet in person during the pandemic, to see them all back here in Amsterdam. So the idea that these three guys had was to basically change the direction of communication. And instead of having the primary systems send out information whenever they felt that there was a need or a trigger event that triggered them to send out information, they would equip them with a passive API, a programming interface where any application, whether it's something that the patient uses, whether it's an external practitioner that needs access to data in a hospital, whether it's an application within the hospital that needs to access these information, they can use this API to retrieve the information they need whenever they need it. So, and this idea, this very first draft of a specification was called FHIR. They coined the term because they didn't want to just, count up the numbers of the versions of the specifications that that HL7 produced, and instead come up with an acronym. And I think that's quite a clever one. First of all, there's a lot of wordplay that you can do on top of that. And also, if you type FHIR into Google, you barely find anything non-relevant to the healthcare specification. So apparently this term doesn't really have any other meaning in any country, in any language in the world. And you find a lot of very precise and meaningful results when you Google it. So the acronym stands for FAST, Healthcare Interoperability Resources. And healthcare and interoperability are probably self-explanatory in this context, but FAST because the focus of this is that this specification should enable developers of client-side solutions to quickly integrate into the existing healthcare environment. So being able to create fast solutions is one of the main focuses of this specification. Resources is another term that you will encounter quite frequently when you dive deeper into the FHIR specification. It's an object-oriented model in FHIR. Like we have different objects like a patient and a condition and an encounter and a practitioner. And we call these different objects that we deal with resources, which is the way that we refer to these bits of information in the RESTful context. Here's a couple of rules that basically determine how FHIR has been developed across the years. The first rule is that we focus on implementers, which is because we want implementers to be able to create solutions fast and easy. So that's the most important part. This is a specification that's specifically written to fulfill the needs of people who want to create solutions for the healthcare space. This kind of sounds like this is obvious thing to do, but it really hasn't been done in the past to the amount that it has been done with FHIR. Quite often specifications were not really implemented until they were finally published. And then it was the implementer's problem to deal with them and to figure out how to create actual software with it. With FHIR, we turn things around and we implement first, and then we decide whether it's good and it's ready to be published or not, or whether we have to go back to the drawing board. The next thing is that we focus on an 80% solution. So whatever your use case is, you probably never be able to find corresponding elements in the FHIR specification for each and every one of your data points that you need to submit. There's probably a large overlap, ideally 80%, but there's always data points that are very specific to your country, to your jurisdiction, to your use case, to the specific vendor or the specific scenario that you're in. And FHIR will not necessarily have an element to cover that. But instead, FHIR gives you the opportunity to extend the specification. So whenever you're missing an element, you can basically introduce your own. The reason why FHIR never tries to have an element for each and everything is that the healthcare sector is vastly different. The way we do healthcare in Germany is vastly different from the way it works in the Netherlands or in the US or in other countries in the world. So there's always stuff that we have in common, but there's always a lot of stuff that is different depending on country, depending on medical domain, depending on your use case. And FHIR doesn't even try to cover all that. FHIR says, keep it as simple as possible, and we'll deal with the stuff that most of these applications and countries and use cases have in common. And whatever we have not dealt with is up to the implementers to decide on their own how to resolve that. The next point is that we want to reuse as much of the established web-based technologies. As I said, basically, FHIR is the attempt to transfer solutions that have already been successfully employed in other domains into the healthcare sector. So whatever works for your other mobile or web-based applications, the way we communicate with a Twitter API or Facebook API or an Amazon API, these are solutions that are quite often used, that have been proven over time, and that developers are quite comfortable with using. They have a lot of experience implementing these kind of APIs. And so we're trying to reuse as much of these technologies as we can. Another point is that in healthcare sector, it's very important to not lose information just because two systems are not perfectly interoperable. So we focus a lot on the human readability of the information, so that whenever machine communication fails, we're still able to just visualize the information. Even if a recipient cannot process it or cannot understand the information, it should always be possible to just display it to the user so that no information ever gets lost. The next point is that it has shown to be an important factor for the success of an API, whether or not there is a community of developers that's using it and that is verbose about using it. So whether they have a place where people can chat, where people can exchange experience, where they can help each other out when they encounter any problems, whether you are able to copy and paste your error message into Stack Overflow and find a bunch of solutions to your problem. These are deciding factors. That's important for developers to have this kind of community to rely on. So with FHIR, we're focusing very much on establishing this community and having a healthy community of developers worldwide. And that's pretty much why we have DevDays. So this is pretty much the most important thing about the FHIR specification, to have these communities of users that help each other out and show their solutions and answer questions and find solutions together. As I said, FHIR dates back to 2011, so it's not really the new specification that everyone makes it out to be. Still called the brand new interoperability standard in healthcare, but it's not that brand new anymore. It's actually more than 10 years old, but it's still not the final version. And the reason for that is, as I mentioned, we tend to test things out before we make them final. So whatever hasn't been excessively tested and implemented and used in real-world scenarios cannot have a final form, because nobody knows whether there's still problems with it unless we have tested it across the board, across the domain, in different countries by different vendors. And this is a process that is still going on. And we actually had the first normative release of FHIR back in 2018, where parts of the specification have reached that status of being final, but not all parts. Because you can quite easily imagine that the amount of testing that has been happening with some of these resources is vastly different. Everyone uses patient resource, everyone tested it. We have tons of productive use cases where patient resources are employed, but we barely have any use cases where vision prescription has ever been implemented and excessively tested. So these resources have different levels of maturity. And whenever there's a new release of FHIR, like we just had a couple of weeks ago with R5, you will see that these resources slowly increase the maturity level, and more of these resources become normative, meaning they have reached a final form where everything has been tested, everything has been discussed, and it's unlikely that there are going to be any more changes in the future. If you're wondering about that gap right here with the FHIR releases, that's pretty much where the pandemic happened. And meetings had to be canceled. People were busy otherwhere in other places, and we had to redirect funding and personnel to other things. And also during that period, there was an enormous uptake in FHIR deployment worldwide, especially where I'm from in Germany. In these years, in the first years of the pandemic, there has been tons of new interoperability scenarios where FHIR has been used. So for Germany, and I assume for many other countries, I know at least of the US too, we are going to be using the R4 version for quite a number of years to come, because so many projects have started in this time period that will be still ongoing until 2025 and beyond. There's no chance that we are going to migrate on any newer version of FHIR. So before you start using FHIR, please make sure what version is the most widely used version of FHIR in your domain. It might be the latest version R5, but it might as well be FHIR R4. I'm quite often asked the question, what FHIR is actually good for? Or can I use FHIR to implement my use case, my scenario? And then they tell me whatever their requirements are. But I don't really listen to what they tell me, what they need. I always say yes, because there's no specific use case that says this is what FHIR has been made to solve, made to do. FHIR basically is a building kit. A kit of different bricks and parts and bits and pieces, and it doesn't really tell you what to do with it. It says, these are the parts that you can use. Do whatever you want. Build a car, build a space station, build a dinosaur. It doesn't, we don't care. Do whatever you want. We are only taking care of defining the different parts that everyone has available and some of the rules on how to use them. And when you look at the FHIR specification, you're kind of seeing this building block kit kind of representation where you have these different collections of similar parts, like for example, security and privacy resources, where you have bits that you can use to express patient consent. You will find parts that you can use to provenance to track the where your data is coming from. We have bits and pieces to represent terminology, value sets, code systems, and stuff like that. And we have different parts for administrative purposes, for clinical information, diagnostics, medication, and so on. It doesn't really matter which FHIR version you use, you will always find in the top level menu in the middle this option to look at all the resources that exist, all the different parts that have been defined as part of the FHIR specification. And then you can see a list of all the different resources. There are about 150, 160, depends on which version you're looking at, different FHIR resources. And these are basically the objects that we have in the FHIR world. And each of them have either a number or this green box with a little n in them. And this is basically the level of maturity. And these range from lower numbers, which means that these resources haven't been widely used and tested yet, and you're still waiting for feedback from the implementers, to normative. These are the ones that have been excessively tested and that pretty much have achieved a final form. There's no expectation that we're going to have to change them ever again. So these will be stable in future releases of the FHIR specification. Whenever you're interested in taking a closer look at any one of these resources, you can just click on them and you will see something like this. It's what we call a tree view, which is basically showing you the structure of any of these FHIR resources. In this case, we're looking at the patient resource, and you can see the individual elements that are defined for a patient, like name and birth date and gender, etc. And these are pretty much the elements that we need in 80% of our use case. You will find nothing in here that is country specific or use case specific. These are just general information that are most likely to be required across multiple use cases. When you create an instance of a patient, when you want to transfer one specific patient's information from one system to another, you are free to either create a JSON represented instance or an XML representation. In this case, I've chosen to show you an XML representation of a patient, but using JSON is just as fine. FHIR doesn't have a preference. FHIR doesn't say XML is more important than JSON or JSON is better than XML. FHIR says if you're implementing a FHIR server, you should be able to support both representations. If you are developing a client application, you can choose whether you prefer JSON or XML and tell the server during communication which representation you expect. In this case, we're seeing an example of a patient with an extension. In this case, this extension is used to put an information in that is country specific, and that is the patient's race. That is something that is commonly captured in the US as part of patient demographics, but it's not as common in different countries. It's even forbidden in Germany, for example, to capture race without any medical indication or reason why. So this is not part of the 80% solution and hence had to be added in as an extension. And countries can maintain their own set of extensions depending on what their specific needs are. Other than that, we have our regular information that should be internationally understood, things like name, gender, birth date, for example. Now, there's different ways to communicate this information. Most commonly used and most obvious is using the RESTful API. As I said, creating this kind of API was the initial idea behind FHIR. And that's pretty much the thing that drives most people towards using FHIR, because that's the thing that doesn't work with previous specifications where we had a message-driven approach. But using the RESTful API is not the only way you can communicate FHIR resources. You should always keep that in mind, even though everyone talks about RESTful API, and it's going to be the thing that you will see most of the time when you look at FHIR implementation. It's not the only way. We can also use FHIR to create structured documents like we used to do with the CDA specification and transfer these documents with whatever document exchange paradigm we use, whether it's IHE XDS or attaching documents to your emails or whatever you do when you transfer documents, you can do that too. We could also use FHIR to send messages between servers to replicate our information like we did with HL7 version 2. That's another possibility. And FHIR basically says, use whatever paradigm you have available to you. Because whenever HL7 were to prescribe a specific paradigm to everyone, it will always exclude some people because they have a national infrastructure that they are forced to use, and there's no way around that. And what FHIR basically says is it's fine. Use whatever you have available to you to transmit your data and simply use FHIR as a content model for your transfer. If you want to know more about documents and messaging, there's a talk right after this one in the next room. If you want to know more about RESTful API, stay here. The next talk in this room is going to be an introduction into the RESTful API. If you have never used the RESTful API, here's a very quick introduction. It's pretty much the principle that every bit of information on a server has an address, a URL. And if you want to retrieve that bit of information, put in that URL and it will show you, in this case, an HTML document. In case of FHIR, you put in the resource URL and request the server to give you that information, and you will receive a FHIR resource. Whether it's JSON or XML, that's up to you. You're just telling the server with your HTTP header which of both representations you prefer. If you don't have the address of the information that you need to retrieve, you can search normally we are searching Google for specific information, but what's actually happening is that our search term is being transmitted as part of the URL to the server. And in the same way, we Google for information in the World Wide Web, we can search for patient demographics or other healthcare information with the FHIR API. Like in this case, we are searching for patients which have first name of given, last name Doe, first name of John, last name Doe, and gender male. And this query is transmitted to the server, and the server will return any patient resource that it finds that matches your query. So the next thing that people often ask me is, do we solve interoperability with FHIR? Will every system that implements FHIR from now on always be interoperable? And the answer is, unfortunately, no, because FHIR is a very open specification that gives a lot of wiggle room to adapt it to your specific needs. And the expectation that people can just use the specification, do whatever they want, and then come together and be perfectly interoperable is about as probable as if you were to give Lego bricks to two different people and ask them to build a house and expect them to return two identical houses to you. That's not going to happen. They have too much opportunity to switch things around, too many different bricks that they could use and put together in many different ways. This is very unlikely to occur. But the solution to create interoperable applications with FHIR is exactly the same solution that enables us to make two people build identical houses with Lego bricks. We need to give them instructions. And these kind of instructions, or implementation guides, as we call them when we refer to standards, they've been around for quite a long time, but FHIR made these implementation guides special. FHIR has implementation guides that are both machine and human readable. So you can not only use them to read through and figure out what to do when you implement FHIR, but you can also pick out parts that we refer to as profiles. A profile of a FHIR resource is basically a description on how to use this resource in a specific context. And it contains machine readable constraints. Constraints might be, for example, the addition of specific extensions that we need in a scenario, or the creation of mandatory elements, the increase of minimum cardinality as it is technically expressed. So these profiles give you a building plan on how to create valid information for one specific use case. And you can use them right away to check whether your FHIR resources that you create are really compatible to these instructions. Because they are machine readable, you can use tools that will compare any instance you create with the specific profile. We call them validators. And since these instructions are FHIR resources themselves, we can share them and search for them across the web like we share any other FHIR resources. If you want to learn more about FHIR implementation guides, I think it's the talk after the RESTful API in this room later this afternoon will give you an introduction on how to create these kind of implementation guides. Now, at last, here's the most important tips that I can give you on how to get started with FHIR. The most important tip is don't just read the specification. It's too huge. It's too overwhelming. You're going to get lost in a rabbit hole following link after link after link. And then you're somewhere deep down in a specification in a place and you have no idea how you got there. So the best thing to do is decide what's your use case. Figure out whether anyone anywhere has ever written an implementation guide on how to use FHIR for that specific use case, or even something that is similar to what you're trying to achieve. And then start from there, because implementation guides will always be more specific, more closer to reality, closer to the problem that you're trying to solve. And they will always limit the scope of the specification that you need to read to what's relevant to you. The next thing is, don't start from scratch. Don't try to reinvent the wheel. There's so much tools, so many libraries, so many open source implementations out there that you can just use and reuse and get your solutions much quicker than if you were to start from scratch. And the next final thing is, don't ask Google, ask people. If you have any questions about FHIR, if you have any issues with FHIR, be wary about Google results, because FHIR has been out there for quite a long time and it has changed over the years and it has always been public. So right now, if you Google FHIR, you can find results back from 2013 that are still out there in the web publicly, but they refer to a version of FHIR that has nothing in common with the way FHIR is right now. And this is something new. That's something you have to be cautious of, because before that, quite often, the people who were able to see unfinished specifications were limited to a very small number of people. But with FHIR, everything has been public all the time. And FHIR has developed a lot over the years. So not every information that you find on the internet is really still relevant and still applicable to the version of FHIR that you use. So if you are uncertain, just use the people out there, use the community, ask them. And the easiest way to do that is to use the FHIR chat. It's free, you can sign up, you can reuse your Google account, you don't have to create any new credentials or anything. Join this chat and you will always find at any time of day a huge number of people that can answer any of your questions. And you will get more reliable information through the FHIR chat than if you're trying to find solutions on your own. So don't hesitate. If you have any issues, any questions, ask people. All right, before I open for questions, one final fun fact about FHIR. As I said, FHIR is a funny thing. You can do a lot of wordplay with it. We have a lot of products that are called things like Spark and Bunsen and anything that has remotely to do with FHIR. In Germany, we have a very own fun with FHIR because it's homonymous. I don't know how that word is in English. Anyway, it sounds the same as party. A German word for party is Feier. And so I'm going to wish you a very wonderful FHIR. Have a great FHIR party at DevDays. And if you have any questions, don't hesitate to contact me. Thank you very much.
Thank you, Simone. Any questions from the audience?
Yeah, how does the implementation guides relate to IHE profiles?
Well, IHE is an organization like HL7, except where HL7 is writing standard specifications, IHE has always been writing these kind of implementation guides, like telling other people how to use specific standards in a specific context. And they've done that for decades. And IHE always looks at a problem first and then decides which standard is most is ideally used to solve that problem. And quite often they have referenced HL7 standards, sometimes version 2, sometimes version 3. In the past couple of years, IHE has always chosen FHIR as the ideal standard to implement whatever use case they are prescribing. And they've also migrated from publishing PDFs, which is what they've done in the past. Whenever they wrote an implementation guide, it was basically a purely human readable document, a PDF. But since like 2 years ago, maybe, they completely switched to writing machine readable FHIR-based specifications. So IHE is basically a producer of implementation guides for FHIR for different scenarios. But we will find implementation guides using FHIR not only from IHE, but also from HL7 International or from different national organizations, depending on who's responsible for writing these kind of implementation guides in your country. But IHE is a wonderful source. If you're looking for implementation guides, go to their wiki, And you can basically filter for FHIR-based instructions that you have them. And you will find that there's around between 30 and 40 implementation guides that are using FHIR as a basic technology.
Okay. Any other questions?
Ramon, this is Pat Guerra, the moderator online, and we have 2 questions in the Whova app. Can I share those?
Yes, please.
Okay. First question from Rika. How much difference is there between the versions of FHIR resources? For example, if there are different digital health systems that are compatible with FHIR already, but with different versions, how much work would it be to get them all to conform with the same version?
I assume you're talking about FHIR releases when you say versions, like between STU3 and R4 or R4 and R5. So it pretty much depends on the maturity level. If you're looking at a patient resource, which has been normative since R4, nothing's going to happen to patient from this time on in the future. So whenever you have a patient R5, R6, R7, it will always be compatible to what we have right now in R4 or used to have in R4. If you're using a resource with a low maturity level, let's say 0 with the first draft, or maturity level 1, which is basically says that the responsible people think that it's good enough to be implemented, but there hasn't been any implementation yet. These resources might change vastly between versions. So you should always be, if you have resources with a low maturity level, you should really pay attention to what's happening in the community. And you can either use this to your advantage and request changes. If you're using a low maturity resource and you're not happy with it, you have suggestions on how to improve it, and go ahead and submit them to HL7 so that they can be considered for future releases. But also, if you're using a low maturity resource and you see other people making change requests and you're not agree with these requests, you can also argue against them. Tell them, no, we are using this resource as it is, and it's perfectly fine for us. So you can either contribute to change, or you can also avoid change, but you have to engage. You have to engage with HL7, you have to engage with the working group that is responsible for that resource, and try to move it in either direction, whichever is better for you. Because these people, these working groups, are really waiting for that kind of feedback to get from you, the implementers, to tell them whether to leave everything as it is, because it's perfectly fine the way it is right now, or whether things need to change for the better.
Mm-hmm. Okay, thank you.
Also, maybe one more sentence to that. There are machine-readable scripts in the FHIR specification that allow you to convert resources between versions. So you can basically just take these scripts and run them and transform your R4 resource into an R5, or R5 to R6, or STU3 to R4. There's always these transform scripts available that you can use.
Okay, thank you. And I know we only have 1 minute left, but there is what I think will be a quick question and answer from Elise. Does or can the resource itself tell you what version of FHIR the sender is using?
The resource itself cannot, because as I said, if it's normative, it can float between versions. So it wouldn't really be helpful to have it in there. Where we can have versions is basically context, like the endpoint that you're talking to, the system that you're communicating with is telling you what version of FHIR it uses in a resource that is called capability statement. And whenever you want to know what your communication partner, what version of FHIR they are using, you can read their capability statement resource, and it will have all the details, all the information that you need to figure out which version of FHIR they are running.
Okay, thank you.
If you had to put the version into your resource for whatever reason, as it's not common, but there might be reasons why you need to do that, you can basically use a metadata field. It's called profile, and there are specific URLs that you can put in there to label your resources with a specific FHIR version if you have to. But again, in most cases, probably not a good idea because your resources should be able to work in different contexts.
Okay, thank you, Simone. Thank you. I think this brings to our end of this presentation. Thank you again, Simone, for this wonderful presentation. And I would thank all the attendees to attend this, for attending this presentation. Thank you.
Thank you very much.